So here we go with our session number 5. So I welcome you all again to the new attendees who have joined soon. So we are here for session 5 with our speaker, Mubashir Husain Rehmani sir, and the session is all going to be about blockchain and its application in communication network. So before we begin with the session, because we already have our speaker with us, I would like to give you a brief introduction about the speaker. So Mubashir Husain Rehmani sir has received this B Engineering degree in Computer System Engineering from Mehran University of Engineering and Technology, and is currently working as an assistant lecturer in this Department of Computer Science, Master Technology. And apart from that, Sir's bio is very, very long because he has done a lot of work. And he has also been ranked as #1 in all this engineering discipline in 2017 from Pakistan Council of Science and Technologies. And apart from that, he is also has published over 100 peer-received publications in high impact journals and transactions and magazines. He has been selected for this inclusion to the annual Highway Cited Researcher 2020 list from Clarivate. His performance in this context features in the top 1% in the field of computer sciences. So sir, when we talk about your achievements, the list goes on and on. So, and we are also running short in time, so the entire conference, virtual conference is over to you, and we would love to attend your presentation. So over to you, sir. Yeah. So you're on mute. Can you unmute yourself?
Okay, can you hear me?
Yeah, so I can hear you and I can even see you also. Yeah.
Okay.
Audible and you're visible.
Okay, so is the virtual background is blurring, or do I need to remove that?
No, your virtual background is good, but your images, they are like quite overlapping each other. So you can try applying it again.
Okay.
Or you can just let it be. It's fine. It looked like without the background, it's also okay. We can start the.
Yeah, good to go.
Yeah, good to go.
Okay.
It's okay. Yeah.
Okay. Can you see my slides?
Yes, so your slide is visible.
Okay.
Yeah.
Perfect. Thank you very much for your invitation. It's my pleasure to be here. So basically, first I will talk about blockchain, giving you some context and background about blockchain, and then I will talk about communication networks. And finally, I will discuss the applications of blockchain in communication networks. So blockchain, as we may know, that there are a lot of cryptocurrencies available. These cryptocurrencies, including Bitcoin, Ethereum, Litecoin, and there are many others. There are more than 100 cryptocurrencies available these days in the market. And these cryptocurrencies are very well accepted around the globe, and they have a very huge market capital. And as you can see, their price back in May 2021, one Bitcoin was more than 50,000 US dollar. So it's a very huge amount. And as you can see, Ethereum was also more than 2,000 US dollar, one Ethereum. So these shows the confidence of people on these cryptocurrencies. And if you know, these cryptocurrencies like Bitcoin, Ether, all of these cryptocurrencies are based on blockchain technology. And blockchain technology is basically based on basically a distributed ledger technology, distributed ledger. So we can define blockchain as a structured linked list of blocks, and each block contains an ordered set of transactions. So this distributed ledger will be distributed across many machines, and they will be using cryptographic hashes, and new transactions can be added, but old transactions cannot be deleted or modified. So these are the basic features of a blockchain. Now, the question is, what is a ledger? So ledger is basically a principal book or computer file for recording and totaling economic transactions measured in terms of monitoring unit of account by account type. And there can be different types of ledgers. For example, sale ledger, which records account receivable. There can be a purchase ledger, which records money spent for purchasing by the company. And there can be general ledger, which keeps different types of record. So if we look at the history, pre-computer, these ledgers and these records were manually saved in registers, copies and registers. And with the invention of computer, these records then moved to computer, and people start maintaining these records over computer using spreadsheets and word processing softwares and different database systems. And then the computer system further evolved. There were many more advancement in these computer systems. So then we have a network of computers where we can have a very powerful database management system which keep records of these data. So we are here at this stage where a database is basically managing all these records, ledgers over the computer network. Now, when the feature for this computer network is that there is a central entity which manages this whole records or ledgers. Now, when we move towards removing this centralized computer from the center, as a central entity, then we can have a network like this, where records saved on several computers, but there will be no central entity to manage it. So so this concept is known as blockchain. So blockchain will basically keep the records like a database system, but without the presence of a central entity. So this is one way of defining blockchain. Now, as you can see over here, there are different blocks in a blockchain. Each of these blocks are linked together through a data structure linked list. So if you use any other data structure, it will be a different type of distributed ledger, okay? Like DAG, DAG, or there are other ledgers as well. But if we use linked list and we link all these blocks in a sequential order and form some other features, then it will become a blockchain. So the first block of any blockchain will be known as the Genesis block. And as you can see, the block will have two components, the block header, which is over here, and the block body. So the block header will have different information like block number, the previous hash value, and the hash value of the previous block. And there will be data transactions where you can save your different types of transactions. So in this manner, the blocks will be linked together, and in the subsequent block, the previous hash value will be included to check the integrity of the data. So this is how blockchain maintain the integrity and immutability in the blockchain system. So as I was mentioning, blockchain is basically a database, but not like the traditional database management system. So there are some common features, and there are some distinguished features which differentiate blockchain from the database system. So both the blockchain and the database system will have the feature of common records. Both keep the common records. However, when we talk about global view and distributed nature, both can have these features. But in terms of central entity, there will be no central entity in a blockchain system. However, in generally speaking, in database systems, there is a central entity. Although there are distributed database systems, but again, the notion of centrally controlling the database is present over there. Then another feature that distinguish blockchain from the database management system is basically consensus management. In blockchain, you have mining nodes that try to reach consensus, while there is a central entity which controls everything in a database management system. One of the unique feature that distinguish blockchain from database system is basically in blockchain system, every node keep the whole data, while this is not possible or this is not applicable to database systems. There are some other features as well. For example, hashing. In traditional database system, hashing is not applied to each data entry. Let's say you have a database system and you are inserting records and adding records. So you will not perform hashing on each and every record entry. However, in a blockchain system, when you add any transaction, hashing is the key operation to secure the blockchain system. Secondly, there's a concept of public-private key encryption, and encryption is generally not applied in database system. However, it is essential requirement in blockchain system. Sequence of record is another key important feature, and you have records which are maintained sequentially in a blockchain system, while this is not the case in database systems. Consensus is another feature that is an essential requirement in a blockchain system, while this is not required in a database system. One of the important feature of blockchain is immutability. It means blockchain records are immutable. That is, no previous entry or transaction recorded in the ledger can be modified. This feature is not present in database system. When you enter something in a database system, you can, using SQL, you can change the entry in a database system or completely override the entry in a database system. But in blockchain system, this is not possible. Once you made a transaction, once you inserted a record, that transaction cannot be changed. If there is a need to change some transaction, or if you want to modify some transaction, you have to make another transaction, and that transaction will be recorded in the subsequent block or set of transactions. So this feature is quite unique in blockchain systems. And finally, the ledger dissemination. Ledger dissemination is very important aspect in blockchain system, where every node, every participant in a blockchain system will keep the state of the ledger, or will keep each and every data of the ledger by its own, while this is not the requirement in a database system. So these are some key features, key aspects that distinguish blockchain from database system. Now, there are some vital characteristics of blockchain. For example, the blockchain system will be decentralized. There will be no central entity or intermediary node or third party to control and validate the transaction. Similarly, the blockchain system will be transparent. Anyone can track the transaction history and track the whole record, who has made the transactions, what are the amount of transactions occurred, who was the sender, who was the receiver. So all these information can be easily trackable in a blockchain system. Blockchain systems are also immutable. It means transactions cannot be changed or tampered. And moreover, non-repudiation means transactions cannot be disowned by the blockchain node. If someone make a transaction, then they cannot say that it's not me who made this transaction. No, one cannot disown any transaction. So non-repudiation feature is another important feature that makes blockchain system very much unique. And finally, we have auditability. It means the user can trace any transaction within the ledger. If we try to classify the blockchain system, there are 3 blockchain systems: public blockchain, private blockchain, and consortium blockchain. So public blockchain are completely decentralized. and anyone around the globe can access this blockchain, can can get themselves removed from the blockchain without any problem. So and all the information will be available by any person. They can see those systems. So the example of public blockchain are Ethereum, Bitcoin. So these blockchain systems are public blockchain systems. On the other side, we have private blockchain systems, which are completely centralized. And these blockchain systems, basically, you can say that they are more closer to the database systems. But again, as I mentioned previously, they will be different from database systems because of hashing, because of encryption, and because of this immutability and non-repudiation. And we have in between, we have a consortium blockchain, which can be considered as partially centralized. So there will be a consortium of nodes, consortium of devices, blockchain participants who will be controlling the actions of the blockchain system. Now, if we look at the layer-wise organization of a blockchain system, we can consider blockchain system into 6 layers. The lower layer is hardware layer, in which we will have the underlying hardware like CPU, GPUs, and it consists of any device on which a blockchain system will be running. For example, we can use our mobile phone to become a node of a blockchain system. So in that case, our mobile phone and the microprocessor or the processor we have on the mobile phone will be considered under hardware layer. Or if we are considering, a laptop or a PC, they can also be considered as a blockchain node. And again, their processing power, computation power, memory, all these things will be considered under hardware layer. On top of that, we have the data organization and topology layer, in which we will be doing some tasks like hashing, data ordering using different methods like linear or DAG, storage, cryptographic algorithm, sidechain, sharding, off-chain, all these aspects will be considered under the data organization and topology layer. We have the network and operating system layer, where we will manage the network and the operating system of a blockchain system. And in this case, we will have the peer-to-peer network. So blockchain actually works on the peer-to-peer network. And we will have the communication mechanism, peer discovery and routing. All these things will be done and will be carried out at the network and operating system layer. On top of it, we have the consensus layer. So consensus layer will be responsible for making consensus among the blockchain nodes. So there can be several types of consensus algorithms available depending upon the type of the blockchain that we are using. If we are using public blockchain, then there are specific type of consensus algorithm. If we are using any other type of blockchain, we will have their respective consensus algorithm. So in that case, we can have proof of work, proof of stake, and Ripple, PBFT, and there are numerous consensus algorithms available in the literature. Then on top of it, we have the virtualization and smart contract layer. So it consists of compilers, smart contracts, Dockers, and distributed virtual machines. All these things will come under the virtualization and smart contract layer. And on the very top, we have the application layer, in which we have different applications using blockchain system. We can have vertical applications as well. We can have cryptocurrency. We can have distributed applications. We can have wallet, and all these things will be considered under the application layer. So this is the general description about layers in blockchain system. So I believe this introduction will be sufficient for the blockchain. Now I move towards the communication networks. So communication networks are all around us, and we are heavily using communication networks in our daily lives and in our communication with other people around the globe. So a network is basically a set of devices connected by the communication link. And there can be different types of communication networks we can see. For example, right now we are using internet. There's a cellular network, mobile phone network. There can be a network of wireless sensor nodes. There can be a satellite network, optical network, Wi-Fi network. There are numerous communication networks available. Now, we can classify these communication networks into two broad categories: wired networks, which consist of, which requires a physical medium, a very physical medium like wires or cables to establish the network, like Ethernet, LAN, or fiber optic. And there is a wireless network in which, again, we will be using some medium, but that medium will be consisting of electromagnetic waves or radio waves. And no wires are required, no cables are required to establish the network. And the examples for such networks are Wi-Fi, mobile phone network, satellite communication networks. So these are few types of wireless networks. Now, I will be focusing more on wireless networks. If we look at wireless networks, there are numerous wireless standards and technologies that we use. For example, when we watch television, we are using some sort of television broadcasting network. When we listen to radio, whether it's AM or FM, we are using some sort of frequency wave, some radio communication network. When we open, our garage door through some device, we are again using some wireless frequencies. When we connect our mobile phone through a local access point, or when we connect our laptop through the router or switch, so we are using Wi-Fi. So what is common in all these wireless standards or communication system is basically the frequency band. So we are using certain frequency bands for communication. And as you can notice over here, the frequency band ranges from lower frequency to higher frequency bands, ranging from kilohertz, megahertz, gigahertz. And these wireless standards or networks can be deployed outdoor or indoor, or a mixture of two. But depending upon the nature of the frequency band, they have a particular requirement. For example, the FM radio communication network operates on megahertz band, and their communication coverage is far, for 30 kilometer, 40 kilometer. And when we talk about GSM or mobile phone communication network, it operates on, sometimes it operates on 800 megahertz, 900 megahertz band, or 1800 megahertz, depending upon, the licensing. So these are the frequency bands on which these different wireless standards operate. So this frequency band is basically a natural resource. Like other natural resources, we have petrol, we have minerals, we have gold, silver. So all these are natural resources. In a similar manner, this wireless radio spectrum is also a natural resource. So here, as you can see on the top right-hand side, we have different frequency bands and we have different radiation types. So it can be radio, microwave, infrared, visible, X-rays. So all these radiation types have different application. For example, X-rays are used for medical purposes. We use microwave for different purposes as well. So here we are focusing on the radio waves, which are basically used in the communication network. So these radio waves, or wireless radio spectrum in simple words, can be divided into two types: licensed band and unlicensed band. Licensed band is the one which can be used only by once you get a license from the government. And unlicensed band are basically those portion of the wireless radio spectrum which for which we cannot pay a single penny. For example, the ISM band or the Wi-Fi network. For the Wi-Fi network, we can just connect two laptops together on gigahertz, 2.4 gigahertz spectrum band. So these two categorization of the wireless radio spectrum is present over there. Now, this wireless radio spectrum is very much precious. As you can see, Germany raised 6.55 billion euros for 5G mobile spectrum auction, and they were auctioning the spectrum block of 420 megahertz. So you can see the worth of this small chunk of wireless radio spectrum. Now, this wireless radio spectrum is basically assigned using fixed spectrum assignment policy. So what is this fixed spectrum assignment policy? If you look at the wireless radio spectrum map by FCC, Federal Communication Commission, USA. So here you can see different color. Maybe it is not visible, but just to give you an idea, that the frequency bands starting from kilohertz going to megahertz and gigahertz, higher values of the gigahertz. So now at the lower frequencies, different colors representing different applications over the wireless radio spectrum. So these are radio communication bands and TV communication bands. And when you go to higher frequency bands, you can see small chunks have been divided into very small chunks, and these chunks represent very higher bandwidth, and they are used for different cellular communication networks or satellite communication or other parts of the spectrum. And in between, there are some dedicated portion of the spectrum which are reserved for government use or military purpose or for ISM band or for other purposes as well. So this is how the wireless radio spectrum is statically allocated through fixed spectrum assignment policy. So if someone wants to use the license band, they need to get permission from the regulatory body, and they need to buy the spectrum portion, and then they can establish their cellular communication network. The same case apply here for any type of communication network or broadcasting network. So here you can see this portion of the wireless radio spectrum is for AM radio. It is fixed for AM radio, and this portion of the spectrum is for broadcasting television signals. Now this is the wireless radio spectrum map of UK Ofcom, and here you can see different chunks of the spectrum are assigned for different purposes. Some are for aeronautical purpose, some are for maritime, and some are for amateur and broadcasting or satellite communication link. So this is how the wireless radio spectrum is statically allocated. But the problem is that when this wireless radio spectrum is statically allocated, the scientists performed some experiments, and they found that there are gaps. There are the most of the spectrum is unused, as you can see over here in this graph. Sometimes the few frequency bands are heavily used. Other time there is no usage, and this is due to the fixed spectrum assignment policy. And basically, we have limited available spectrum in today's wireless network. So this results in inefficiency in spectrum usage and creation of these spectrum holes. So in order to make these communication network efficient and effective, we need to fill these gaps, like making these spectrum holes filled, so that we can effectively and efficiently utilize the wireless radio spectrum, because we cannot come up with new portion of the spectrum. So we have to use the existing wireless radio spectrum. Now, scientists were thinking that how to deal with this issue. The problem is that this, if you see this spectrum unoccupancy or underutilization of the spectrum is due to the fixed spectrum assignment policy. So what they said is that let's try to do some sort of dynamic spectrum assignment, and they came up with a new paradigm which is known as dynamic spectrum assignment policy. And this dynamic spectrum assignment policy will be carried out using a device or using a network which is known as cognitive radio network. So cognitive radio is a radio basically that can be programmed and configured dynamically, and it can change its transmission and reception parameters. And there are two types of users in a cognitive radio network. One is the primary user, and the other one is secondary user. So primary user will be the licensed users, while the secondary user will be the unlicensed user. So basically, the cognitive radio nodes will opportunistically use the wireless radio spectrum. What they will do, they will try to identify the spectrum gaps, the spectrum holes, or underutilized spectrum, and then try to use that portion of the wireless radio spectrum to build their own network or to start their communication. So in simple words, let's say if we have a mobile phone, and when we insert a SIM in the mobile phone, basically we are paying money, we are being charged to utilize the wireless radio spectrum of the telecom company that we are for which we are using their network. Sorry for that. So with a cognitive radio device or a cognitive radio capability in our mobile phone, we can sense which portion of the spectrum or which portion of the network is not being utilized by any user. Okay, and then we can make a free call and we can use their network. So this is the main concept of cognitive radio network. And this cognitive radio network has huge applications. I will explain you in the later slides. But just to summarize, this cognitive radio network has 4 basic functionalities. The spectrum sensing phase, where the cognitive radio device will detect the unused spectrum. And in spectrum management, they will try to select the best available channel. And in spectrum sharing phase, they will coordinate access to this channel with other users so that other users know what are the channel conditions. And then if there's a licensed user trying to use the licensed channel, they will vacate the channel and move to the next channel, next free channel, while maintaining seamless communication. Now here in this diagram, I try to show how a cognitive radio network will work. So here on the left-hand side, you have a primary network. And this primary network has the primary base station and primary nodes. It can be any type of licensed network, whether it can be a TV broadcasting system or mobile communication system. And on the right-hand side, there can be 2 possibilities. You can have a cognitive radio network with infrastructure, where you will have the cognitive base station, or without infrastructure, where you will not have any base station. In any case, the cognitive radio nodes will be sensing the spectrum and try to utilize the unused spectrum for their communication. There are different types of primary user occupancy activities. So when we use mobile phone on packages, free call packages, we can have a long call. So this can be result in this form of activities on the frequency band. It can be termed as long-term PR activity, where you have long portion of the spectrum frequency band being utilized, and then there are times where we do not use for long terms this spectrum band. There can be high PR activity as well, where we use heavily the spectrum band, and a very short period of time where we will not use the spectrum. And it can be seen in rush hours or in urban areas. Low PR activity can be seen in remote areas or less peak areas, where sometimes the spectrum will be occupied for a short instant of time, and the rest of the time the spectrum will be free. And there is intermittent PR activity, where you can have the short on and off periods, which you can find in bus station and railway station. So basically, the goal of the cognitive radio node is to identify these gaps, these white spaces, or these unused spectrum, so that they can build their communication network. There are several applications of cognitive radio networks. They can be used in behind the enemy lines. When the military goes to behind the enemy line, they need to establish their communication network, and that communication network can be established using communication equipment, and that communication equipment generally is cognitive radio network. So the whole military is dependent upon these cognitive radio devices for their communication. And there are other applications as well. For example, you can use cognitive radio in smart grid, in sensor networks, even in cellular networks, and in Wi-Fi networks as well. Cognitive radio networks have another application when you have natural disasters like floods or earthquakes or different types of other events, natural disaster events. Then your communication infrastructure get destroyed. So for rehabilitation work or to facilitate organized help, you need a communication network which can be deployed in a very quick time, and that can be useful to help the rescue team members and NGOs, to help the to help the people who have suffered from the natural disasters. So these cognitive radio devices can be very helpful in providing connectivity and internet access. So this was about few slides about communication networks. Now, how we can use blockchain in communication networks? Well, if you see the literature, there are several use of blockchain in communication networks. When we talk about, let's say, a green IoT, a green Internet of Things, blockchain can be used to secure wireless power transfer. So when energy harvesters will be there, so these energy harvesters will be trying to harvest the energy to the IoT devices, which are energy constrained devices, so that energy transfer can be managed and recorded through blockchain. Similarly, in multimedia networks, blockchain has a important role. One can use blockchain for video integrity and fake video tracking, auditing of video content, and peer-to-peer video content sharing, and privacy of video content. So there are various applications of blockchain in multimedia networks. In Wi-Fi, blockchain can be used for congestion avoidance, for anonymous access control. In cellular networks, blockchain can be used for management of roaming. Sometimes when we move from our country to any other country, we will be on the roaming. So blockchain system can be used for negotiating on our behalf and managing of the roaming prices and calls in a cellular network. And in Internet of Things, IoT, blockchain can be used for identity management, authentication, and wireless power transfer. So these are few general applications of blockchain in communication network. Now let me just consider one particular case in more detail, which is cognitive radio network and blockchain technology. So as I mentioned, this cognitive radio network is basically there in order to use the wireless radio spectrum in an efficient manner. And as I mentioned previously, the wireless radio spectrum is a natural resource asset, and there was unused wireless radio spectrum due to the fixed spectrum radio assignment policy. And this cognitive radio devices basically help to identify those unused spectrum and build the network. So blockchain can be used in spectrum management. Okay, so as I mentioned, the spectrum is very precious natural resource. So blockchain can be used for this spectrum management. And you can see over here in this diagram, you have the spectrum regulator, which provide usable frequency chunks, and then these chunks are assigned to the BTS, and then they can be used by primary nodes, and then they can also be traded by the secondary users. So these basically, this complete cycle can be managed through wireless radio spectrum. This complete wireless radio spectrum cycle can be managed through blockchain. There's another use of blockchain in spectrum trading. So when you trade the spectrum, okay, you can revolutionize the spectrum trading process using a smart contract, using smart contracts, which are the essential part of blockchain system. New business models for spectrum trading can now be realized, and future trading of spectrum can now be possible upon completion of a certain condition. It can also reduce the business process time, and it can make the system more autonomous by removing the third party from the trading. There is another very important use of this blockchain in spectrum trading. So traditionally, what has been done is that this spectrum trading is done for long period of time. But when you use blockchain technology, you can perform the spectrum trading for a very short period of time, considering even for hours, minutes, and even seconds. And this will enhance spectrum utilization and improve the revenue generation. So this was all about the applications of blockchain technology in different communication networks. So here I conclude my presentation, and I want to just share you that I have a textbook written on this blockchain system and communication networks, which is published by Springer. And there is another book on the applications of blockchain on fog and edge computing, which is published by CRC Press. So if you require any detailed information how blockchain can be applicable to communication networks, you can refer to these books. So if you have any question, most welcome.
Thank you so much, sir, for such an amazing and such a smooth session and such an interesting session as well. So I would encourage the viewers and the listeners to come up with questions if they have one. And also, so we have one question in the chat box that they're asking that, do you think that how we can use it in educational field? So this is the one question that we had in the chat box.
Yes, yes, in education field, for example, in universities, we have degrees, we have degree awarding procedures, degrees. So one of the problem that we encounter is that how to verify those degrees and those certificates. So if a blockchain system is used, then one can easily verify the degrees and certificates through blockchain system in education sector. So this is one application, and there can be other applications as well. For example, for the management of records of students, but definitely there are some points which we need to consider before applying blockchain system to the educational sector.
All right. Thank you so much, sir, for answering it. And apart from that, if we don't have any questions such, I guess, because I think people understood your presentation so well, so they do not have any question. Thank you so much, sir, for your precious presentation and your time. And by this, we end this session. Thank you to all the viewers and all the attendees, and thank you so much.
Thank you. Bye. Bye.